Good afternoon, everyone. So my talk will be about adversary attacks on neural networks. I'm affiliated with FIT STU. So what are neural networks? Probably most of you already know. One neural network is an AI algorithm mostly designed for classification problems. For example, image recognition. And one network consists of interconnected nodes, also called neurons. And the information is transmitted from the input neuron to the output neuron. For example, in this picture, we have a neural network that consists of one input layer, one output layer, and two hidden layers. It's supposedly to be designed to distinguish between pictures of cat and dog. And in this example, we have a picture of dog, and the output of the network says that the network has 90% of confidence. The picture is a dog, and 10% of confidence that the picture is a cat. So before I go to more realistic attacks, I will introduce one of the earliest works that discuss about adversary examples. In this paper published in 2014, the authors consider adversary examples as inputs formed by applying small but intentionally worst-case perturbations to the examples from the dataset. So here, the worst case depends on the attacker goal. Most of the cases, the attacker goal is to cause misclassification with very high confidence. And sometimes the misclassification can be targeted in the sense that the wrong class is chosen by the attacker. So in this picture, we can see that the original photo is a panda, and it's correctly classified to be panda with 57.7% of confidence by the network. And then the author showed that with a very small perturbation, we get a second picture. And for human eyes, we can't see the difference. However, the neural network misclassified to be gibbon with 99.3% of confidence. And next, I will show some realistic attacks. So this one was published in 2016. The authors show successful impersonation with eyeglasses. So in these figures here, we can see the first row corresponds to attackers, and the second row corresponds to victims. And the attackers just wear these eyeglasses, like they printed, and then they can be misclassified to the target victim. So how did the authors achieve this? They translate the whole problem into an optimization problem with certain goals. Like, of course, they need to predict the victim to predict the attacker to the victim, and then they also want to achieve printability with a commercial printer. So the color range should be within the range for a printer, and then the smoothness in the sense that the contrast of the colors is not too big, and then they also want to achieve robustness so that with different angles and the light, the picture can still be misclassified. So with this optimization problem, they use an algorithm to solve the problem, and the output is the values of pixels on these eyeglasses. So the attacker just print it, wear it, and they can be misclassified by the network. And this example is to achieve invisibility with infrared light. In this paper, the authors figured out that they consider a scenario that the attacker is a criminal, and the police would like to find the criminal using face search. How the face search works is that first of all, there are the civilian videos, right? The videos will be split into frames, and the face portion will be identified in those frames using a landmarking model. And this landmarking model is the neural network that we want to attack using in this paper. And this face, once it's identified, it will be cropped out for later usage. And so the authors, in their experiment, they realized that this infrared light generated by LED cannot be seen by human eyes, but it can be captured by camera sensors. And with enough LED, this landmarking model doesn't work anymore. So basically, the criminal can wear a cap like this, go around, and his or her face can't be found using such a face searching algorithm. And the last example I want to talk about is a road sign misclassification. So these authors propose to use extra lights on the road sign to cause misclassification. During the day, you can use a mirror, and during the night, you can use a torchlight. So we have 3 rows here. The first row is the original classification result. The second row is the simulation of their analysis tool. And the last one is the real life scenario, like the real attacks they carry out. So for example, if the speed limit is 30 kilometers, they just use a mirror to cause a light around this 3, and then it's misclassified to be speed limit of 80 kilometers per hour with very high confidence. And for example here, the last one, original sign says the street of left. It's correctly classified, but with a torchlight here, it will be misclassified to be ahead only with a very high confidence. So it's very interesting attack, and they demonstrated those attacks on public neural networks used for famous traffic sign data sets. Okay, that is all. Thanks for your attention. If you have any questions, you're welcome to email me.